Hello everyone, welcome to class. I know things are going to be a little bit different this week and you just got to bear with me. I'll explain why in a second. Today we're looking at week 19, which is our last week of semester 1, and today is going to be day 1. You will not have mystery numbers this week, but just for your point of reference there. Um, this week, like I said, today is technically Monday, so happy Martin Luther King Day. I know, understand that there are no live lessons today. Today is supposed to be a makeup day, but I also wanted to give you a chance to work ahead. So what I'm going to do today is I'm going to go over Tuesday and Wednesday's lesson, and you can work on that on your own pace then. And I actually will not have class on Tuesday and Wednesday, and that should give you some extra time working because today will be our last actual lesson of content. And then Thursday we will meet, we'll review, we'll talk about last minute things you should be working on. And then Friday you'll have your test and that'll be the end of the semester. Just a few last minute things here. Office hours I will still have on Wednesday and Thursday. That'll be normal. That will not change. And then your assignments on Friday need to be in by 5 p.m. unless otherwise discussed with me. So today we're going to be working on 8.06 and 8.07. The first one, 8.06, is all talking about linear systems of linear equations, but we're going to put them in context of word problems. And then 8.07 is actually linear inequality systems. So we've looked at the lines in particular, now we have to look at inequalities. And we've looked at graphing inequalities, so this is just graphing two inequalities together on the same graph, so kind of putting both pieces together. So let's look at some word problems to start us off here. Now the steps for solving a word problem we've talked about in the past are step 1, identify. So what's the information that you're given? What's the information that you know? What are you missing? What's important? What's not important? Then find a strategy. So are you going to write an equation? Are you going to draw a picture? Are you going to act it out? What are you going to do? And then in step 3, you actually want to set it up and do the work. Step 4, you're actually going to do the math and solve it, and then you always go back and check. Now, you can see in step 1, 2, 3, and 4, and 5, this focuses more on when our strategy would be to solve an equation, then that's when this comes into play. So what we have here is 1, read the problem, decide what unknowns are asked for. So what are your variables? What are you going to be looking for? And then choose those variables for step 2 and use them with the given facts. Now we'll do this together, but this is important. So once you choose a variable, it has to connect to some sort of information there. I like to go back and reread the problem. That way you know what you're expected to do. And then you're going to write an equation, solve that equation, and always check your answer. So kind of similar steps here, but now we're really focusing on our strategy is point blank choosing an equation. So let's practice this. We'll go through some examples of how to work through this, and this is actually on part of your 8.02 written test, so please make sure that you are paying attention. Okay, so we're going to a county fair, and the admission fee is $1.50 for children and $4 for adults. On one given day of the fair, 2,200 people enter the fair, and $5,050 is collected. And we want to figure out how many are children and how many are adults. So we're going to go through and we're going to highlight some important information. The first thing that I think is important is that it costs $1.50 for children and it costs $400 for adults. We also know that 220 people entered the fair and $550 was collected. So we have some information. So we went through and reread the problem, just like the first thing said, and decide what unknowns and what are we given. Now you need to go to step 2 and choose some variables. So I'm going to say that I'm going to put a C for children and an A for adults. And we're going to connect that information to a fact. So I know that for every child that comes, it's going to cost $1.50. And I also know that for every adult that comes, it's going to cost $4. So now I have my two facts. I've connected those variables to information. Now we need to reread the problem and write an equation. So the admission fee is $1.50 for children and $4 for adults. On one given day, 2,200 people entered the fair and $5,050 is collected. I want to know how many children and how many adults attended. So I can look at this next and say, okay, well, I know that if I add these two together, that it's going to equal $5,050, right? Because if the amount of children plus the amount of adults at how much it costs, it should equal that total amount. So that's one of my equations. But I also have to look at the other equation and think, okay, how can I find this answer? Because right now, all we have is one piece of information. We just have one fact about the total. So we need the total cost. We need to find the total people. So I also can say, well, the amount of children plus the amount of adults is going to equal 220 people. And so now we have a system of equations, right? We have two specific equations, and now we need to solve them just like we did. We could graph them, we could substitute them, or we can use the elimination where we add or subtract them. This time around, I'm actually going to use the substitution method. So I'm going to go through and I'm going to solve this bottom equation so we get one variable by itself. And I'm just going to have the children be by itself. So I'm going to subtract the adults. And you can see that the amount of children is going to be 2,200 people minus however many adults there are. And that's logical because if we have 2,200 people, some are adults, some are children. Well, if we take away the amount of adults, all we have left is our children. So now you can see I really have my two equations. I have my one here and my one down here. I also know that I have one solved for a variable, so now I can substitute it in. And I'm just going to get a blank page here so we have some more room to write. So I have my first equation, $1.50 per child plus $4 per adult, and that gave us 5,050. And then I have the amount of children equals 2,200 people, take away the adults. So now just like we talked about with substitution, we take our blob and we put it in wherever we see the variable in the other equation. And in this case, that would be with C. So I have $1.50 times the amount of children, which we now know is the total, plus the cost of adults. And you can see now the variable for the children has disappeared. We're only left with the A's for the adults. So that shows us that we are now solving to find out how many adults there are. Yes, this is going to take some work. We talked about what substitution does. And so we're just going to go through. We're going to multiply 1.5 times the 2,220 people. We get 3,300 minus 1.5 adults. We're distributing there, plus $4 times the adult will give us the 5,050. Okay, now I just solve my equation and I start combining like terms. I add and subtract until I can get that A all by itself. So what I have here is I have 1.5 negative 1.5 plus 4. And I get 2.5. Adults. I take away the 3,300. And I'm left with 1,750. Equals the 250 per adult. Now I divide by the 2.5 and I find out that there was 700 adults. So I can say that there was 700 adults. Well, if we know that there are 700 adults, we could do 220 minus 700. I'm sorry, 2,200 minus 700 to get 1,500 children. And that would be how we'd solve our problem. So yes, it took a lot of work. There was a lot of steps involved. First, we had to go back and write our equations. Then we had to make them able to be substituted in. That was down here. And then we actually had to go and do the substitution and the work. Once we found that there was 700 adults, it was easy to find that there was 1,500 children. Then we just subtracted. Let's look at one more example here. So the school that Stefan goes to is selling tickets to a choral performance. On the first day of ticket sales, the school sold 3 senior citizen tickets and 1 child ticket for a total of $38. The school took in $52 on the second day by selling 3 senior citizens tickets and 2 children. Find the price of the senior citizen as well as the price of the child. So I'm going to go through, I'm going to highlight my information, right? I don't need to know that they're selling tickets to a choral performance. And I don't need to know if it's the first day or the second day. But I do need to know that at one point there was 3 senior citizen and 1 child ticket, and that cost me $38. I also need to know that 3 senior citizen tickets and 2 child tickets now cost $52. So right away you can start thinking, hey, I have these equations. I'm going to start connecting this information. I'm going to use some variables here. So I'm going to put senior citizen, and I'm going to put a C for child. And I'm going to say, okay, so if I have 3 times S, that's 3 senior citizen tickets, plus 1 children's tickets, that costs $38. I also have 3 senior citizen tickets, plus 2 children's tickets, and that now equals $52. So right away you can see that I'm starting to get my equation. Now we don't actually, on this equation here, we don't actually need the 1c, right? We only need that c. So I'm going to erase this because now you can see that it's starting to look like, hey, that's the equation. I'm going to solve for my variable. So I'm going to get this c all by itself. So in order to do that, I subtract 3s from both sides. So on my top equation now it's c equals 38 minus 3 senior citizens tickets. So now I'm going to use these 2 equations, and I'm going to substitute it in just like we did with the last equation. So I have 3 senior citizen tickets plus 2 children's tickets, and that cost us $52. And then I had the cost of a child's ticket is $38 minus the price of 3 senior citizen tickets. From there, this is my blob, and I'm going to substitute my blob in wherever I see this C. So I have 3 senior citizen tickets plus 2 times my blob, which is 38 minus 3s. And that'll give me that $52. So now I have 3s minus 6s, and I get negative 3s plus 76 equals 52. And now I'm going to solve for my s.